Before we talk about the actual rationals, let's talk about fractions. Because adding and subtracting is probably the hardest to do.
Oh.
Because.
You always start with these easy.
Exactly. Can I combine those the way they sit now? No. The reason is why.
Yeah, why can't you do that though?
I have to have common denominators. Now, once the denominators are the same, I just combine the numerators over that common denominator, right? So when you find a common denominator, we like to find what we call a least common denominator. Because it helps us, and I'm going to really kind of dumb this down a little bit as far as with the number stuff, so that hopefully you see when we throw the polynomials in there, the connection. All right, so if I've got least common denominators, tell me how you find the least common denominator. The least common multiple. The LCD is the same thing as the LCM of the denominators. Now, does everybody know what a least common multiple is? Okay, if I looked at 3, the multiples of 3, 3 times 1 times 2 times 3 times 4. I'm going to stop right there. The multiples of 2 are 2, 4, 6. And I can stop because I found the smallest one that they have in common, right?
Yes.
Does that make sense to everybody? Okay. So that would tell me I need to force the bottoms to be 6.
So you have to multiply the 3 by 2 and then the 2 by 3.
Exactly. Is that confused?
What?
Because that would make the first one be 4 over 6. That would make the second one be 3 over 6. I need to force the bottoms to be the LCD, the least common denominator, or the LCM.
So both of them would have to be.
That's going to be an improper fraction.
Right. And what do you do?
Can't you do like 1 or something? Like
What's-
the 1 or from?
When you add fractions, what do you do?
Across, yeah.
So it's 7 over. You go across on the top, but you leave the bottom the same, right?
Yeah.
So it's 7 over the 6, which was the LCD, right? So let me ask you this.
Can you keep improper fractions?
Yeah. Yeah, you need me to go back? Let's say I had
Have what?
this.
Line 5. I have actually,
Okay. So, because, yes, my LCD, and it's going to help you if you write them in completely factored form. So, in other words, write them by their multiples. So, 2 over 3 times x plus 5 over 2 times x times x. Right? So the least common denominator here would be, Brianne, say it one more time. 6x. You're telling me what I need on the first one. Okay? So I'm looking at the coefficients in front to see what the least common multiple is of those, and then...
Of what?
Huh? The least common denominator of these two.
So 3x, the least common denominator of that.
The least common denominator of the two of those is going to be 6x squared. Remember, a common denominator can be found by multiplying the two together. But the least common doesn't include repeated multiples in there. So what I mean by that, it does not, but in order to combine them, I'm going to have to make it happen.
Okay, so 3 and 2, the least common denominator is 6.
Correct.
And then in order to get 3x equal to 2x squared, you have to times it by 2x. So when you do 2x times 3x, it'll equal 6x squared. And then on the other side, if you times that by 3, the denominator will be 6x squared.
Correct.
Alright.
Hold on, what?
All right, so think about it like this. You can't take anything away from any of the denominators, right? But you can multiply by something. I need to force these two to look exactly alike.
Yeah.
We know that the least common multiple of 2 and 3 is 6. We know that's where the 6 comes from.
This is the way she said too.
Okay, but the only way to make x and x squared look the same by adding something to it, well, multiplying something to it, is to multiply this one by an x. So that's how we come up with the LCD of 6x squared. What if, and I'm going to tell you this before I show you. In general, to find the LCD, once they're both completely factored down, and by factored down I mean even if you had a 6x in the bottom, completely factored down, remember when you do like a prime factorization? So 6 is 2 times 3 times then the x, okay? So once it's completely factored down, even down to prime factorization, if you write the first denominator, this is to find your LCD. If you write the first denominator and then include the missing factors from the next, that should give you your LCD. So you should say, write the first denominator, include any missing factors from the next. So in other words, 3x, and remember this is 2 times x times x. I don't have a 2, I have an x, but I don't have a second x. So the LCD would be 6x squared. It's got to be completely factored first. Yeah. Let's practice first just finding the LCD or the least common multiple. Let's say it was 4x squared. Let's pretend these are in the denominator of a fraction. This is the hardest part about the adding and subtracting, is finding the least common denominator, the LCD. All right, so I really, really, really need to factor completely first. Well, look at the first one. Let's look at the first one.
4.
Take out a 4. Okay. Anything else?
The last one you said.
Well, can you do anything else with that first one? Yeah, what? Difference of 2 squares. So I've got 4 times x minus 2, x plus 2. Does that confuse anybody? Remember, we're pretending this is in the denominator. We're just finding a least common multiple right now. All right, let's look at this one. And Juliana said take 6 out of everything, and she's right.
It would be 4. 6x squared minus 4x plus 4.
Can you factor that any further? Yeah. Yep. It's a perfect square trinomial. X minus 2, x minus 2. Now, I mentioned prime factorization to you. If you do prime factorization of 4, what do you get? 2 and 2. So 2 times x minus 2, x plus 2. Does everybody remember how to do prime factorization?
What is that?
Okay. Where you start with a number and you break it down, keep breaking it down in multiples until they're all prime. All right, so the prime factorization of 6, 2 and 3. You do remember it or you don't remember it?
No, I was for the school and
2 times 3. Why does it have to be 2?
I'll show you as soon as I finish this one. I'll show you how to do
It
it.
ain't hard though.
It's not.
And then you can't pull out the negative.
Okay, so now my question is, looking at these, what is the least common multiple? So remember I told you you could completely write the first one. I got to have, everything in each one has to be included in the LCM, okay? You just got to find out what you got to add to it. All right, so I got 2 times x minus 2 times x plus 2, right? So I've got 2 2's, an x minus 2, and an x plus 2. So looking at the next one,
Mostly have in common is x minus 2.
it is. I've already got a 2 in here, right? I don't need that. Do I have a 3?
No.
I need that. Do I have an x minus 2? Do I have a second x minus 2? No. Because everything from this one must be in here, and everything from this one must be in here. So you don't have to repeat from one to the other, but you do have to repeat if the repeat happens in the same piece. I feel like that sounded very confusing.
It's not,
I'm sorry.
it's not cute.
Well,
If
okay,
it's
so
already squared, then you can't.
yeah, so what you want to do is you want to look, like I would look at this one and I would go, okay, let me double check. Do I have a 2? Yes. Do I have a 3? Yes. Do I have 2x minus 2's? Yes. Now let's look at this one. Do I have 2 2's? And I'm going to do a different color here.
Yes.
Do I have 2 2's? 1, 2.
Yeah.
Do I have an x minus 2?
Yes.
Yes. Do I have an x plus 2?
Yeah.
So everything from both of them is in there now.
Oh, yeah.
So my LCM is, or my LCD, 2 times 2 times 3, 12, times x minus 2 squared times x plus 2. Does that make sense?
I get
Let me show you, Tanner, if you don't know the prime factorization. Okay. Yeah, so like if I had 12, give me 2 things that multiply to give you 12. And it doesn't matter what you use. 4 and 3. Which of these can you break up with something other than 1? 4. What do you get? Can you break anything else up any further? Then the prime factorization of 12 would be 2 times 2 times 3. Does that make sense? You just keep breaking each number down until you can't break it down any
What does that
further.
have to do with this?
Because it helps us find the least common denominator. Because if I hadn't done that,
Can you break down the numbers that you were given?
if I hadn't done that, I would have a 24 in here because I would have put the 6 and the 4 instead of the 12. 12 is the least common multiple of 4 and 6.
No. They probably get chapter 2.
Okay. Shut up, Shami. We start chapter 3 today.
Oh.
All right.
Yeah, I know they take
Let's do another one.
So what do you have to do with that?
Like, take good sleep in that class.
Better have 106 in that thing.
Try this one on your own. These are both denominators. Find the LCM of these two. All right, well, let's factor it together. What can you take out of the first one?
5
Wow.
x squared minus
Yeah.
What else?
9. 4
But what can you do here?
x
Oh,
plus 3 x
Yeah.
minus 3.
There's the 2 squares. 5 is already a prime number, so it doesn't break down any further. All right, you said you can take a what out of here?
4
4.
Yeah.
You got x squared plus x plus 9.
Yeah.
Ooh.
That's all I'm saying. What do I
It doesn't factor anymore, so that's a factor on its own.
But we gotta do the prime factorization of photo.
Mm-hmm.
2 times 2.
2 times 2.
Wait, so that's where we use it?
Mm-hmm.
Yeah.
All right, so let's do the LCM or the LCD if we're in a
You
fraction.
could do 3 and 3 for the
But 3 plus 3 is 6.
3 times 3.
Right, would be 9. This can't be factored.
Okay.
Nothing multiplies to 9 but adds to 1.
Yeah.
All right, so I write the first one. Do I need these? Both of them? One of them?
I don't know.
None of them? Do I need them?
Both of them.
Both of them. Do I need this?
Looks like
Yes.
that's 22.
I need everything.
I needed everything. Which means my least common denominator was simply a product of the two denominators. 20, x minus 3, x plus 3,
Why isn't it just 2 squared?
x squared plus x plus 9. You could write it that way if you wanted to, no. All right, does that make sense, finding the least common denominator?
Yeah.
Yes.
I know we not about to solve.
I'm fixing to show you. I want you to practice finding it before I threw it all together. Right? I'm going to show you. There were no repeats between the two. There were no common factors between the two. Then you'd only need one of them, as long as 1 4 occurred in each. Like if this had a 2 times 2 on the end also, I would only need to write it once because it's already in there. Yeah. All right, let's do one. Are y'all ready?
Yes, I'm prepared.
Okay, so remember the rules.
That's not even half of the problem.
Mm. Mm.
Probably 1 4 2.
All right, when we let me set you up with a couple of rules first. When we add or subtract fractions,
Crap.
Boy, we better have 2 problems on.
Take it back, I'm not prepared.
okay? When the denominators we find the LCD first, right?
Yeah.
Like if I go back to that 2/3 plus 1/2, we found that LCD, and that LCD was 3 times 2, right? Yes, no, maybe so?
Yeah.
All right, and so then what we do is we multiply the top and bottom by what it's missing. And missing when you look at the LCD.
So 6.
Right. Well, I want you to look at it as if it's broke down prime factorization, this has got a 3. What does it not have in the LCD? A 2.
Why?
Because we're going to have polynomials that it's going to be.
But how did you get the LCD?
We wrote the first one.
Okay.
They're already broke down. And then we included the second one. So this one is missing a 3, so we do top and bottom. So we multiply the top and bottom by what's missing from the LCD. And then we combine the numerators over the LCD. I'm going to give you a second copy. So the rules of adding fractions are going to be the same. All right, 7 over 9x squared plus x over 3x squared plus 3x. Now remember, before we can find the LCD, we must first do what to each denominator? Factor it. Factor it completely.
The
So
denominator.
3x times 3x.
So 7 over, well, I'm going to go ahead and write this prime factorization. How is it? What is it? 3?
Times 3. Times x times x.
Yes. Plus x over 3 times plus
1.
1. Come on, guys. Y'all don't leave me hanging on the easy ones. Okay. All I did was factor. I took a GCF out of the bottom of the second one, and I just rewrote the first one as in prime factorization. Does that confuse anybody? No, yes, no, maybe? Okay. Now let's find the LCD.
3.
Write the first one. So, yes, 3, 3, X, X.
Look at me, guys.
I need 1, 3. Do I have 1, 3? Yes. I need 1 X. Do I have 1 X?
Yes.
Yes. I need an X plus 1. Do I have an X plus 1?
No. Hey.
Look at the first fraction. What's missing? What do I need to multiply this by to make it look exactly like this?
X plus 1.
X plus 1. I got X plus 1. I got X plus 1.
And then you would have to multiply that by 3.
3 X. Does that make sense?
Well, where did 3x and all that come from? 3x come from.
Because I need 2 3s and I've only got 1, and I need 2 X's and I've only got 1. What?
When you multiply by 3x, you that as 9x squared.
Yeah. So if you want to write your LCD as 9x squared times x plus 1, that's fine. So now I've got 7 times x plus 1 plus 3x squared over 9x squared times x plus 1. All right, so now here's what I have to do, because here's where it's a little different. I have to simplify this. Now, we did a lot with simplifying rational expressions, right? I can't cancel yet. Why can I not cancel? This is where everybody wants to go ahead and go, gone.
Yeah.
Why can you not do that?
Is it
Look at it.
parentheses?
Is every plus or minus in parentheses though?
No.
No.
You would have to divide 3x by 9.
I would have to expand the top out. Only the top. So I'm going to have to expand anything.
Only the top?
That does, yeah, because the bottom's completely factored. But anything that has a plus or minus not in parentheses. Does that make sense? So because this has got a plus that's sitting outside parentheses, that means I'm going to have to say 7x plus 7 plus 3x squared. Now, you can't really tell the way it sits right now, but if I rearrange this a little bit, I have a quadratic on top.
I love quadratics.
I swear to God.
Never mind, I'm not.
You sure?
Yeah.
So now my question, because we talked about how do we simplify by factoring and canceling out any terms that cancel. Can you factor that quadratic?
Set it equal to 0.
Well, we're not solving quite yet. You're getting ahead of the game. Can you factor? Is anything multiplied to 21 but add to 7? No. So that means this is completely simplified.
Why didn't we do quadratic? Why couldn't we do that?
That's going to take 60.
Y'all are so crazy. What?
Can we do one more? No.
This step?
You got 2 A's on this.
No, right? Was more than 9x.
Here.
Then you like this?
Which one? Oh, we're going to do a couple more. What? Which one?
The thing that's
Oh, your
right
pizza
above the
stuff.
word simplify.
Oh, goodness.
Yeah, it's like, okay, I understand why you multiplied the x plus 1. I don't understand why you multiplied the 3x.
So if you just take the very first denominator and write it, you got that. And then you multiply by anything that's missing in this.
Like, equal.
Right.
Same bottom.
Right.
But why don't you guys, like,
Why did I multiply this one by 3x? Because I needed it to be 9x squared in front, and right now it was only 3x. So I'd need another 3 and another x to make it 9x squared. All right. Remember, your first step is to factor completely everywhere, okay? And factoring completely includes prime factorization. So look at the first denominator.
Hold on, let me write the question down.
I'll let y'all try this together.
Hey.
Prime factorization here is what? 2 times
Hey, I'm at 4.
x and x.
No, I didn't.
Here, guys, we can take a 5x out. We're left with x minus 2. So my LCD, take the first.
Write the whole first one, then.
2 times 5 times x times x.
Yeah, I was right on this.
I don't need a 5, I don't need an x, but I do need an x minus 2.
Yes.
The first one needs a what?
X minus 2.
X minus 2. The second one needs a 2 and another x.
Oh, that's what they need.
So am I confused?
Not really.
All right.
Times x times,
So this is 3 times x minus 2
so 3x.
plus 2x times 2x. All over. And now I'm going to put my LCD together a little bit more. 10 x squared x minus 2.
And then you,
Can I cross stuff out yet?
nope,
Nope. Why?
because you gotta do these.
See that big old plus in the middle?
That will be 2x times 2x.
That's right. So it's going to be 3x minus 6 plus 4x squared all over the LCD. And if I were to rearrange that in standard form up top,
4x squared plus 3x minus 6.
over
10x squared x minus 2. And then nothing happens with that.
and that's right, because nothing multiplies to negative 12 but adds to 3. And so it's done.
Negative 12 and 3.
Tell me what you think.
Negative 12 and 3, what?
If you put this in the box, nothing multiplies to, negative 24, I'm sorry.
Hold on.
Oh, wait.
No, I missed what you said.
Negative 24 adds to 3.
What on that part are they?
Oh, no, never mind. I'm thinking
No,
8.
never mind.
I'm thinking 8 and 3, and I'm getting all. No, it cannot be factored. It's done.
I was